Morning to all. Today I am going to discuss about the chapters on nuclei. The first part of the session I am just going to explain about finding the radius of the nucleus and the interaction of the alpha particles with other atoms and some of the important questions. Maximum part of the questions were asked in old question papers. That one we have explained in a little more detail. You just go through on this one. If you are having any doubt, you just send your doubts on comment section so that I just try to explain this one and remaining important all the chapters what I have covered here. I just given in the description. You just go through on that. Of this session is about nucleus radii. See, they have given atomic number. Atomic number of atom here is iodine is 53. Mass number they have given 125. And radius of iodine. If you want to find out the radius of an atom, mass number is most important. See here in this one. See, I just mentioned here, radius of an atom is proportional to the mass number. Mass number I just mentioned here, and the cubed root of mass. See, usually atom will be depicted like this. A is about atomic number. See, Z is about atomic number. Z is atomic number here, and A is about mass number. Now this one, so R is proportional to the mass number. From this one, R is equal to, that is about proportionality constant R naught A power 1 by 3. Now you just substitute the value here. R naught value they have given, that is 1.2 into 10 to the power 15 means a fermimeter. 10 to the power minus 15 meter fermimeter, right, into A. What they have given here is 125 whole power 1 by 3. Now what you can do here is, see, I just mentioned here 1.2 into 10 power minus 15, and this one I just mentioned as 5 cube. 5 cube is 25, 125, and whole divided by 3. You just cancel here. What you are having here is 5. 5 into 12 is 60, and 5 into 1.2 here is 6 into 10 power minus 15 meter. That is fermimeter. So answer in this case here is, question here is, compare the radii of two nuclei with mass number. They have given only mass number 8 and 64, and also compare their densities. Now I just mentioned here. See, for this one already we know R is the previous problem we have seen. From this one, R1 for a first radii, R1 will be equal to, I just mentioned here, R1 will be equal to A1 power 1 by 3, and whole divided by R2, that one will be equal to A2 power 1 by 3. Now A1 and A2 they have given the value. A1 here is 8 power 1 by 3 and A2 here is 64 power 1 by 3. Now this one you can mention like 8 here is 2 cube whole power 1 by 3 here, and this one here is 4 cube whole power 1 by 3. Now you just cancel here. So what you are going to have here is 2 by 4, that is 1 divided by 2. So in this case R1 divided by R2 will be equal to 1 by 2, that is R1 is to R2. So R1 is to R2 here is 1. See, I just mentioned here 1 is to 2. But what about the compare the densities? The densities here is rho 1 by rho 2. That one will be equal to 1 is to 1, because mass number here is independent. Mass number here is mass is mass number. I just mentioned here mass number is independent to density. So answer in this case, this one. Important question. This one last year in old question papers they have asked this question. The radius of an oxygen nucleus. So oxygen nucleus radius they have given. With the help of this one, we have to find out lead nucleus radius. See here, already you know, I already have mentioned here. I just mentioned this one. See here all the atoms that can be depicted with the help of this formula. A is about mass number and Z is about atomic number. Now according to this one, or see here, R is proportional to a power 1 by 3, or even R is equal to R naught a power 1 by 3. This is about the general formula. From this one, R2 we are going to find out. So R2 divided by R1, that one will be equal to R naught, and R naught will be cancelled here. Anyhow, I just mentioned this one. For R2 here is 205 whole power 1 by 3 whole divided by R naught into here mass number here is 16 whole power 1 by 3. Now R naught will be cancelled here. So 205 divided by 16 whole power, I just mentioned here, whole power 1 by 3. See, from this one, 205 divided by 16 here is, that is 12.5. So this one 12.8 for whole power 1 by 3. Now see, for this one, what you are going to get the answer in this case, that will be around 2.33. Now I just explained the steps how I am getting here. See, from this one, R2 is equal to R1 into 2.33. So R1 value already they have given, that is 2.8 into 10 power minus 15 into 2.33. So what you are getting that answer in this case, that is 6.55 into 10 power minus 13 meter. So answer here is this one. Okay, now I will explain how you are getting this answer. See, in this case, see, I just explained this one. So you just remember this idea how you are going to get. See, this one 12.8 whole power 1 by 3. Now how you can define here is a 12.8, you can mention like 128 divided by 10, that is 12.8. So whole power 1 by 3, right? This one 128, how you can mention here is, this one here is 2 power 7, and this one you can mention like 2 into 5, that is 10, that one power 1 by 3. See, from here, see, from here 1 2 will be cancelled here, so you are having 2 power 6, 2 power 6 whole divided by 5 whole power 1 by 3. Now in this one I just mentioned here whole power 1 by 3. So this one here is 2 power 6 by 3 and 5 power 1 by 3. So that one 6 power 6 by 3 here is 2 square, that is 4. 4 divided by cube root of 5. Now this one from here 4 divided by cube root of 5, you can mention like this one I just mentioned here in this case. So this one you can mention like here is 5 square. So 5 square, this is cube root, see here, and even cube root of 5 square. So here what you are going to have here is 4 into cube root of 25 here, and this one here is cube root of 5 cube. Cube root of 5 cube here is you are having 5, and 4 into cube root of 25. So this one 25, how you can mention here is 2 into 2 into 2, 2 twos are 4, 4 twos are 8, 3 into 3 into 3, that is 339 9 3 27. So it is in between 2 and 3. So approximately I just mentioned here almost nearer to 3. So I just mentioned here 4 into approximately you just mentioned as 3 only divided by 4. So that is 12 divided by 5. That will be approximately, see, approximate answer this one here is uh, 2.92. I just mentioned as 3 here. So 12 divided by 5 here is you can mention this one 5 3s are 15, or even 2.4 will be there approximately. I just mentioned here 2.4. Now I just mentioned that one as 2.33. Like that you just substitute, you can get the answer. Problem. uh, Two stable isotope. Isotope in this case, atoms which is having same atomic number, 3 will be the same, but mass number is differ. So hope you remember this one, ZXA. Z will be the same, A will be differ. That is about isotope. In the isotope, have a respective abundance, that is a presence, how much if they are going to mining of this one like minerals, how much they are getting the isotope here is maximum 7.5 percentage of this isotopes is available, but the remaining 92.5 percentage, whenever they are going to find 92.5 percentage of this lithium only will be available, but this is very less will be available, that abundance percentage they have given. These isotopes have a mass number, masses they have given. Mass value here is 6.01 and 7.01. So this one is 7.0 and this one is 6.0. Then what they are asking here is the atomic mass. Now for this one, how you can find out the atomic mass here is, now I just mentioned here in this case, atomic mass of lithium. See, I just mentioned in this case atomic mass of lithium. We can find with the help of the formula, that one m is equal to, that one m1, this one eta 1 is about abundance over here, and m2 eta 2, and divided by this one here is eta 1 plus eta 2, or even you can mention like n1 or n2. So abundance in this case, I just here as per the formula I just mentioned as eta 1 and eta 2 here. See, now you just going to substitute the values here. Now I just substitute the values of this one. For the first one, mass of the isotope first lithium here is 6.01. I just mentioned as only, see, I just mentioned this one 6.01512. See, for better understanding, I just write on everything. And next time I just next steps I just show you. So see, this one abundance here is 7.5 percentage, and this one here is 7.01600 into. So here is abundance here is 92.5 percentage, and divided by, first I just substitute all the values here, divided by 7.5 plus 92.5. So the total here is 100 percentage. Now this one I just mentioned here 6 into, round up that value, 6 into 8 plus this one here is 7 into 92, I just mentioned as 93 here, whole divided by this is 100. Now from here I just mentioned here 6 into 8 48 here, plus 7 into 93, 1 balance is 2, 691 divided by 100. Now in this case you just add together. So what you are having here is 9 is there, and this one 9 plus 4 13, and this one so 7. Yeah, approximately you just mentioned here 7. So I just mentioned as approximate answer will be around 7. So 7 is the mass number here, approximately I just mentioned. So answer in this case here is approximate 7. Okay, coming to this problem and a previous one, both combined together, they have given one question as a previous year question paper. You just go through on this one for NEET, and even sometimes similar like this problem they have asked in JEE mains also. See here, boron has two stable isotopes. So they have given two isotopes, same atomic number difference in mass number. Their respective mass value they have given, and the atomic mass value they have given. What they are asking here is abundance of first and second one. Last time they have given about abundance and isotopes over here, isotope masses they have given. They are asked about atomic mass. Now this time they are asking about abundance. Now I just mentioned here in this case first one we just mentioned here, mass of boron isotope 1. So what they have given the mass here is M1, I just mentioned here, that one 10.012, and the second one the same mass of boron 2 I just mentioned, boron 2, that is M2 here. M2 value what they have given here is 11.00931 unit. I just mentioned as only 3 digit, I will take it over here. And abundance I just mentioned here as abundance for first boron. We can mention this one here as eta 1. Eta 1 will be equal to, for example, x percentage. The same in this case abundance for boron 2, that one I just mentioned here eta 2. So that one here is remaining thing will be second isotope. So 100 minus x percentage. Right. Now see here, atomic mass of boron, what they have given here is atomic mass of boron they have given here, that is 10.81. From this one formula I just mentioned here, M is equal to M1 eta 1 plus m2 eta 2 whole divided by, so here eta 1 plus eta 2. Now we'll substitute all the values. First one, mass. See, this one I just write down in a different in color so you can understand here. So I just put over here. See, from this one, mass here is 10.811. That one will be equal to 10.012. I just take up to here into x, that is eta 1 x percentage, plus 11.009 into abundance here is 100 minus x. Now this one whole divided by this one here is x plus 100 minus x. So what you are having here is 100 percentage. From this one, see, this 100 you just multiply over here. So what you are having here is 1081.1. That one will be equal to, that is 10.012x. Now you just multiply this one, that is 1100.9 minus of 11.009x. Now you just simplify over here. From this one, x is equal to, so what you are going to have, x will be equal to, now I just mentioned here, this is 19.821. so this one you just do it. See, according to this, what you are going to have here is 0.996. That one, see, 0.99 means it will be approximately 1. So what you are going to have here is 19.89. See, from this one, see, from here, this is about x value, then 100 minus x we are here is what you are going to have, that is 100 minus 19.89. so this is for in case of boron 1 and this is for in case of boron 2. You just mention here. See, boron 1 we mention as x value we found it here, and boron 2, that is 100 minus x. From this one, what you are going to have here is, now I just mentioned this one, this is 80, remaining thing is 80.11 percentage. So from this one, what you are getting, that answer in this case. Question. A heavy nucleus at rest, its break into two fragments which fly off with velocity is in the ratio of 27 is to 1. So V1 by V2, that is in the ratio 27 is to 1. See here, the which is having a less mass, that will move very fast. So that you can understand here, mass M1 will be little less when compared to mass M2. So that this is moving little less in speed. Then the radii of the ratio of C here, you can understand this one. See, from this one, R1, it should be less when compared to R2. See, from this one you can see here, R2 should be less and R1 should be less when compared to R2. See, from this one, these two should not come, only A or B are the answer. Now I will explain with the help of this one, you can understand here. Simple concept. See here, the object which is having a less mass, that can move very fast. The object which is having a more mass, that will move little slow. See, according to this one, I just mentioned. See here, M1 V1 will be equal to M2 V2. So these two options won't be there. Already I told, whether it may be this option or this option, we just confirm here. See, from this one, M1 divided by M2 will be equal to, see, I just mentioned here, V2 divided by V1. Already we found out here, V1 is to V2 here is 27 is to 1. See, from this one, V1 divided by V2 will be equal to 27 divided by 1. See, but what they have given here is V2 by V1. V2 by V1 here is 1 divided by 27. Now hold this steps up to here. From this one I just mentioned here. Suppose density, how you can mention here is, say this one I just mentioned here, in this case density. Now this one, density will be equal to, so density here is mass divided by volume. Now from this one, mass is equal to, mass here is, mass is equal to uh, density into volume. Now from this one, I just mentioned here mass m will be equal to 4 by 3 pi r cube. Then density here is, this is about the volume. Then here density I just mentioned as rho. See, from this one m is proportional to r cube. So m1 will be proportional to r1 cube and m2 will be proportional to r2 cube. Similar in this case, m1 by m2 here is r1 cube divided by r2 cube. That one will be equal to 1 divided by 27. How you can mention here is 3 cube. Now take a cubed root on a cubed root on either side. You just mention here cubed root on either side. So what you are having here is r1 divided by r2 cube and whole power of 1 by 3. So from this one, see the same one, 1 by 3. Answer here is 1 by 3. See, from this one, r1 is to r2 will be equal to 1 is to 3. This is the answer. This is quite interesting, but have to put little work over here. See this one, binding energy per nucleon. So this is about binding energy per nucleon versus mass number curve. So this is binding energy versus mass number. It shows the curve as shown in the figure of W, X, Y and Z for 4 nuclei indicated in the curve. The process would, see what they have mentioned here is, process would release energy. Now this is the process. Energy is released. When the energy will release here is when binding energy of product. See here, this one here is reactant and this one is product. When binding energy of product, it should be greater than the binding energy of reactant. So according to this one, you just mention here. So first, I just mentioned in this case what is product and what is reactants. According to this one, I just mentioned here. First one, see in this case, for first option, I just take the one. So this is Y is about a reactant. That one will be equal to product. See, binding energy of reactant should be less when compared to the product. That means product should have a binding energy is more. So for Y, how you can mention here is, see Y this one here is 60 into this one 8.5. I just mentioned here 60 into 8.5. That one will be equal to 2 times of Z. You just mentioned here. Z here is 30 and 5. Now here is 30 into 5.0. I just mentioned as 5. 60 into now I just mentioned here 60 into 8.5. So what you are going to have here is this one for Y, 60 into 8.5. Now I just mentioned here um, 48 and this one here is 510 and here is 30 into 5 here is 150. So what you are having here is 300. Now in this case, since this is 510, reactant is maximum. Here is energy is observed, energy is not released. Next case I just mentioned here, W will be equal to X plus Z. W just see here, according to this one I just mentioned here, W here is 120 into 7.5. That one will be equal to X again, that is 90 into 8 plus Z here is 30 into 5. Now similar one I just mentioned here, 120 into 7.5, that will be approximately 900 and 90 plus 90 into 80 here is 720 plus 150 here. Now you just add here what you are going to have here is 150 here, 0 7 870. Now this is 900 here and this is 880 and even this side is increases. Now third one is W will be equal to 2Y. W value here is 120 into 7.5. That one will be equal to 2 into Y. What they have given here is Y here is 8.5, that is 60 into 8.5. Now this one 120 into 75 here is 900 and 2 into 8.5 into 60, that is 510. So what you are having here is in this case that is 1020 and this one here is 900. In this case this is maximum. So according to this one, energy in this case, energy is released. Energy is released, and the remaining two case energy is absorbed. Now the fourth one also we just confirm here. X will be equal to y plus z. X value here is I just mentioned as 90 into 8. That one will be equal to the same 8.5 into 60 plus, and z here is 30 into 5. Again you just mentioned here that is 150, and this one here is 510. Already we wrote this one. 9 into 2, that is 720 here. So this one if you add together, this value here is 660, and this one is 720. Again in this case also the reactant will be maximum when compared to the product. So answer in this case, this one. Interesting. And last year they have asked this question. In a previous year question paper they have asked here. See, 1 gram of hydrogen is converted into 0.993 gram. See, 1 gram to 0.993 gram of helium in a thermonuclear reaction. See here. See, 1 gram which is converted into this one. So the difference is here is 0.007 gram that has released as an energy. So the energy released here. See, according to Einstein mass energy equivalence, hope you know about this one. Einstein, famous Einstein equation here is E is equal to mc square. Now this one, this velocity of light and this one mass is going to convert into an energy. So the differences in the mass between this one, it's converted into an energy. That energy has been released here. Now I just mentioned here. So the mass difference, that we call it as mass defect. Now I just mentioned here, mass defect will be equal to 1 gram of hydrogen which can be converted into 0.993 gram of helium. So the difference here is 0.007 gram. Now while substituting this one, we have to mention this one in kilogram. So I just mentioned as 0.7 into 10 power minus 3 kilogram. The kilo, see in this case, kilo and 10 power 3 will be cancelled here. So what you are having, 0.007 gram. See from this one, here is energy released. See here I just mentioned here, energy released according to Einstein mass energy equation. Here E is equal to del m, that is about changing mass into c square. Del m, that one we found out the value 0.007 into 10 power minus 3, and c square here is 3 into 10 to the power 8 whole square. Now this one again you can multiply over here. So 0.007 into that one 10 power minus 3 into 9 into 10 power 16. Now this one you just mentioned here, that is 0.063 into this one 3 will be cancelled here. So what you are having here is 10 power 13. See from this one again you can mention here. So what you are going to have 63, I just make into 63 here, 63 into 10 to the power of 3 power will go. So from here 10 to the power of 10 joules. So energy in this case here is 10 to the power 10 joules. Which is similar to previous problem. See here, in previous problem they have given difference in mass. Here they have given the mass directly. That is 1 microgram of uranium is completely destroyed in atom bomb. How much energy has been released? That's what they are asking here. So this one I just mentioned here. See, according to mass energy equivalence, in this case E is equal to mc square. Now already they have given mass value, that is mass value. See 1 microgram, I just mentioned here 1 into mu g is about 1 microgram. 1 microgram in this case, that is 10 power minus 6 gram. You have to substitute this one in kilogram. So I just mentioned here 1 into 10 power minus 6 into 10 power minus 3 kilogram. So what you are having here is in this case 10 power minus 9 kilogram. This is mass here. Now how much energy has been released? Here mass has been converted into an energy. Here mass value here is 10 power minus 9, and c square, that is 3 into 10 to the power 8 velocity of light whole square here. So this one 10 power minus 9 into 3 into 10 to the power 8, that is 9 into 10 to the power of 16. Now from this one and this one you can cancel here. See, from here, this is direct question, you can easily get the answer. 9 into 10 to the power of 7 joules. See here, this much amount of energy. See this one, already you know this one. See, 1 joule is equal to 1 into 1.6 into 10 to the power minus 19 electron volt. So this one, in this case, 1 electron volt, I'm sorry, this one I just mentioned here. In this case, not this one I just mentioned here, 1 electron volt is equal to, say in this one, see here, now I just mentioned 1 electron volt. See how much energy has been released, 1 microgram. See here, 1 electron volt is equal to 1 into 1.6 into 10 power minus 19 joule. Right, from this one, 1 joule is equal to 1 divided by 1.6 into 10 power minus 19. So instead of joule, you just mention here this value. This will come in mega electron volt. That much amount of energy will release. So that's what, 1 microgram of substance is more than enough. It will produce more amount of energy. That's why uranium is high rich energy material, a rare earth material. So that's why while holding uranium, that is a radioactive element, holding this one is a offense, especially for in India. Not only in India, anywhere in the world, you should not hold this one. Problem: what is the approximate energy released by the complete annihilation of alpha particle? First one, alpha particle is helium 2He4 atom, this one. And what do you mean by annihilation? Annihilation is the reactions where where the particles and its antiparticles, for example, electron is the particle, antiparticle here is positron, and both collide together in this case, and it will be disappear. So that what happened here is it release an energy. That one, this they have mentioned here is annihilation process. So in this one, alpha particle and its antiparticle both combine together, and it will be collided and it will be disappear. At the same time, it release an energy. The most common annihilation process that will occur in our earth here is that is about electron and its antiparticle, that we call it as a positron. Now from this one I just mentioned here, in case of annihilation of alpha particle, now I just mentioned as alpha particle here is alpha particle I just mentioned here. This one here is helium, which is having, see here, 2 as an atomic number and 4 as the mass number. Mass number which gives about the total mass of an atom. See, for this one, for one atomic mass unit, so one atomic mass unit here is, I just mentioned, will be equal to 931 mega electron volt. See here what we are having here is 4, that is 4 atoms over here, 4 mass of an helium atom. So I just mentioned here 4 atomic mass unit here is 4 into 931 mega electron volt. So what you are going to have here is 3724. You just multiply here. This is the answer in this case. This is similar, like we have seen this problem in case of an atoms. You just go through the two presentations over there. See here, an alpha particles having an energy of 10 mega electron volt collided with the nucleus of atomic number they have given 50. Then the distance of closest approach will be, see this one we have seen in case of Rutherford experiment. The first diagram I have mentioned here in the previous one, you just go through on that so that you can understand here. So what they have given here is, I just mentioned here, energy. In this case, kinetic energy will be equal to, they have given that energy, that is about 10 mega electron volt. That means 10 into mega means 10 to the power 6 electron volt. Now they have given that energy. Already we know that formula here is K is equal to, I just mentioned here, K is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R. Even I just mentioned similar like this in case of Coulomb's law, there 1 by 4 pi epsilon naught R square will come. This is about in this case kinetic energy. So here is Q1, one charge is about atom collided with atom, that is about atomic number they are given, that is Ze. Another one is about the helium, that is 2 electrons over there, divided by 4 pi epsilon naught into R. That one will be already they have given that energy, that is 10 into 10 to the power 6. That one will be equal to 1 by 4 pi epsilon naught here is 9 into 10 to the power 9 into Z value they have given, that is 50 into 2 into E square. E square you can mention over here, E square is nothing but 1.6 into 10 to the power minus 19 and divided by R. From this one R is equal to, see here you can cancel over here, so what you are having here is 10 power 3 is there. Now and even this 10 also you can cancel here, so what you are having 10 square is there. So from this one R is equal to 9 into 10 square into this one here is 100 is there, and this one 1.6 into 10 to the power of minus 19 whole square. Now you just simplify this one, simplify it, and you can get the answer of 144 into 10 to the power minus 16 is there. Or else this one, see, this is what you are going to have here is in electron volt. See, everything is in an electron volt. See here, even in this case also kinetic energy, I just mentioned here kinetic energy in electron volt. Suppose if you are going to find out this one you have to convert into a joule. See here, 1 electron volt equal to similar concept here, 1.6 into 10 to the power of minus 19 joule. See, according to this one electron volt, you just substitute here so that it will be cancelled, so you can easily get the answer. Or else what you are having here is 14.4 into 10 to the power of minus 15 meter. This is about in case of answer to this question. The mass defect for the nucleus of helium. So they have given the helium atom mass defect here is 0.0303 atomic mass unit. Now the binding energy per nucleon in mega electron volt. Now in this case, see here binding energy of nucleus, how they can find out here is binding energy equal to del MC square. Now what you mean by binding energy? This much energy is more than enough for the electron to hold, and even the proton which can hold the electrons in the attraction, so that the electrons which will be revolving around the nucleus and to avoid to go inside the nucleus at the same time. See here, this one we can mention in mega electron volt here is a del MC square is this one, you can mention here 931.5 mega electron volt. And here this one is binding energy per nucleon. See what they are asking here is binding energy per nucleon. Now, in this case, what I'm going to mention here is first we are going to find out what is the binding energy. Now, I just mentioned here binding energy will be equal to, so del m c square, that one I just mentioned here from this one, del m into 931. I just round off, I just take this value 931 mega electron volt. That one will be equal to, they have given already del m value, that is mass defect 0.0303 into 931 mega electron volt. Now this is about the binding energy. Now what they are asking here is binding energy per nucleon. So here this is about nucleon, they are asking binding energy per nucleon. Suppose in case of alpha particle, this one you can mention here 2He4. Nucleon in this case, inside the nucleus, what are the things will be there? Number of protons plus neutrons. See this one you can mention here, that is about mass number. So you can rewrite this one as a binding energy per nucleon. Here is you can mention like a mass number. Already you just found out the value. Binding energy here is 0.03 into 931 mega electron volt. This one already which is in mega electron volt. This one divided by 4. Now you just simplify here, simplify it. What you are going to have here is 7. Now you just cancel it and multiply it to this one. So what you are going to have here is approximately 7 mega electron volt. So answer in this case, problem, binding energy per nucleon of lithium they have given, and helium alpha particle. For these two binding energy they have given, the value here is 5.6, and this one is 7.06 mega electron volt. Next one, then find the energy of proton in the following reaction. See this one, the energy of proton in this reaction we are going to find out. What is that energy? First, I just rewrite this equation one more time. See here, this one here is for in case of lithium 3Li7 plus proton here, that one will be equal to 2 times of helium atom, that one 2He, helium particle here is 2He4. Now this one binding energy in this case here is this one product, that is about here product minus of reactant, that is about changing energy or even energy difference over here. See what you are having, the product here is 2 times of binding energy, this one binding energy of helium minus reactant here is, this is about binding energy of lithium here. Now you just mention here 2 into binding energy. Previous problem we have seen binding energy. See here, binding energy per nucleon, that is binding energy per atom here is, we can see about mass in the previous problem you can see here. So this one from here, what you are going to have here is 4, this one you just multiply over here. So 4 into what they have given in case of helium here is 7.06 mega electron volt minus of this one 7 is there, that is about, see here in this case you can understand here, this is 7 for the mass number in case of lithium and this is 4 for the mass number of helium. So 7 into what they have given, the value here is 5.6 mega electron volt. Now you just mention here, you just multiply this one. So 4 into 2 here is 8, 8 into 7, that is a 56 here, 56.48. Now 8 into zero point 0.6, 0.06 here is 48 minus this one 7 into 5.6 here is 29.2. So what you are having here is, you just find the difference. So 7.28 mega electron volt. So answer in this case, still another few problems are there. The on nuclei will be discussed in next part. From this sessions only we are having two parts, and atoms you are having only two parts. From 4 sessions for 4 presentations you are having two questions for your NEET and EAMCET problems. So especially for this one atom and nuclei, you can expect two questions. One from nuclei, one from atom. You just go through on all the important questions which was asked in the previous question papers was concentrated more, and that was discussed. That even I have mentioned and any of the corner of the slide question paper, old question paper, that questions and all previously discussed and even asked the questions in the question paper. You just concentrate that one little more extra. Remaining will continue and the link will be given. You just subscribe that one. Thank you.